YouTube is live. I should be live on YouTube any moment, and then we can start. Am I live on YouTube? Live on YouTube. I'm live on YouTube. We can start. Hello, guys. And since in the last stream, at least I had a lot of fun learning CMake, the basics of CMake, today we're going to learn the fundamentals of CMake, where our goal is to go through at least half of the official CMake tutorial that we started in the last stream. This is the tutorial. We went through step 0 and step 1. This was the absolute basics, and we learned a lot. And today, my goal, all of the steps are 12. If we count the 0, the goal is to go through at least half of it. So to finish with step 5. And the first task is to open the step 2 page of the official CMake tutorial. And that's what we're going to do. Step 2. What we did from last time is, let's go in the dev folder in CMake. Here, this is a couple of folders that we downloaded from this official tutorial series. And each page, that is step 0, step 1 to all of them, has a folder. And each one is like a simple exercise that you go through. Here we compiled just one C++ file. We did that successfully. That was extremely hard. And then we went through with step 1, where this was actually a lot harder, surprisingly harder. Here we had 2 folders, the tutorial one and math functions. Math function one was a library that we created, and the tutorial one used the library. The library had like a CMake file, and the tutorial one had a CMake file as well, and the whole project had another CMake file that combined everything together. At first, we did everything in this single CMake file, and then we distributed it to these 2 files. I wasn't planning on doing another stream today, but this tutorial was so fun. I was planning to do it on my own, but like, I think you guys would miss out if I didn't stream it as well. Like, I think it's worth sharing with everyone because I didn't know about this tutorial, and like, for me, it's a hidden gem. Like, I always learn from YouTube tutorials, and like, I've never appreciated like these kind of basic tutorials, like text. Who reads text these days? Like, where's my TikTok short? Okay. Step 2. I assume we will work as surprise in the step 2 folder. And what will we have inside? We have 3 files. Exercise 1, CMake. I don't know why it's CMake when we worked with text files. This is again CMake, but let's just say that the file extension doesn't matter. Like, let's say it's nothing of that much importance. Okay, what is the tutorial? Step 2, CMake language fundamentals. In the previous step, we rushed through and hand-waved several aspects of CMake language, which is used within CMake list.txt. Yeah, this is what we used, and that's why I'm surprised why it's like ends in CMake. From the step 2 folder, it doesn't end in the txt, so it must be something interesting. In order to get useful, building programs as soon as possible. However, in the wild, we encounter a great deal more complexity than simply describing lists of source and header files. That's true. The projects we looked at, like example CMakes in the wild, This is one of them. Like it gets way more complex than the few lines we got in our tutorial. And this actually uses like sub projects. Like it has at subdirectory, like what was it? Subdirectory? Yeah, add subdirectory. Like for example, add subdirectory source is another CMake file. Here, the source folder. It's another CMake file that is also complicated. So, yeah. In the wild, we encounter a great deal more complexity than simply describing lists of source and header files. To deal with this complexity, CMake provides a Turing-complete domain-specific language for describing the process of building software. So, like, if writing code wasn't simple enough, your build system, you will code your build system as well. Understanding the fundamentals of this language will be necessary as we write more complex CMake files and other. Yeah, what CMLS? That was from the previous tutorials. I forgot. CMake. Yeah, the text file. CMake files. The other language is formerly known as CMake language. The language formerly known as CMake language, or more colloquially as CMake lang. So this is CMake. The CMake language is not well suited to describing things which are not related to building software. Okay, it's just for building software. Okay. Because we want to fully explore the language features, this step is an exception to the tutorial sequencing. It neither builds on step 1 nor is a starting point for step 3. This will be a sandbox to explore language features without building any software. We'll pick back up with the tutorial program in step 3. So this is kind of an exception tutorial, but it must be important since we've not skipped it. Best practices and solutions to real problems. However, for this one step, we're going to be re-implementing some built-in CMake functions. We don't write your own list append. Okay, we'll be just doing actions here that we will not be in the real world using. The only fundamental types in CMake lang are strings and lists. So strings for files, like file paths, and lists for lists of file paths, I assume, because we are building projects. Every object in CMake is a string, and lists are themselves strings which contain semicolons as separators. Any command which appears to operate on something other than a string, whether they be booleans, numbers, JSON objects, or otherwise, is in fact consuming a string, doing some internal conversion logic, language other than CMake lang, and then converting back to a string for any potential output. We can create a variable, which is to say a name for a string using the set command. Okay, with set, we are setting a value to a variable. Okay, brilliant. A variable's value can be accessed using brace expansion. For example, if we want to use the message command to print the string name by var. Okay, this is our print line. Can we make a game with CMake? a variable's value can be accessed using brace expansion. CMake B, CMake lists. Okay, we compiled, like we generated like the project with CMake dash capital B in the build folder. And then we compiled the executable with CMake dash dash build and then the build folder. So what does this do? Like, does this like compile the actual CMake? Script mode. It informs CMake this file is not intended to have a project command. We're not building any software, instead using CMake only as a command interpreter. So if we were to make a game with CMake, this is what we would use. Okay, good to know. Because CMake lang has only strings, conditionals are entirely by convention, of which strings are considered true and which are considered false. These are supposed to be intuitive, true on, yes, and strings representing non-zero numbers are truth, while false off, no, zero ignore, not found, and the empty string are considered false. However, some of the rules are more complex than that, so taking some time to consult the if documentation on expressions is worthwhile. Recommended to stick to a single pair for given context such as true, false, or on off. Yeah, it will be really confusing if for true, sometimes we use true, other times we use yes. So yeah, consistency matters. So it's easier to read. As mentioned, lists are strings containing semicolons. The list command is useful for manipulating these and many structures within CMake. Expect to operate with this convention. As an example, we can use the for each command to iterate over a list. So here this is a variable and we give it, so this variable is actually a list since it's a string with a semicolon. So it's this and this. List append. So we append to this list curly. Now we have Mo, Larry, and curly. The message, whatever this is, contains, and then the value of this. So this will be the message. Yeah, this is the message. Yeah, so a list is a string that separates the elements with the semicolon. And then for each like string in the list, we can say like hello using each one. Yeah, that's, oh, okay, now we are in exercise. Okay, this is where we actually learn. CMake allows us to craft our own functions and macros. This can be very helpful when constructing lots of similar targets like tests for which we will want to call, okay, like tests, like who makes tests? Haven't built a test like in centuries, for which we will want to call a similar set of commands over and over again. We do so with function and macro. Okay, macro, it gets two arguments and prints macro argument and macro. Oh, this is my macro. This is the name of the macro and this is just the argument. Okay, so it's not two arguments. And then a function, the name of the function, like what is this weird syntax? The argument of the function, which uses our macro. Okay, this is confusing. New line from function. And then from macro. And then my function. From top level. Yeah, from top level, from function, from macro. And this is some weird way of doing it. Like with many languages, the difference between functions and macros is one of scope. In CMake lang, both function and macro can see all the variables created in all the frames above them. However, a macro acts semantically like a text replacement, similar to C macro. So any side effects the macro creates are visible in the calling context. If we create a change or change a variable in a macro, the caller will see the change. So basically here where we say use the macro, it literally replaces this macro with the message. Function creates its own variable scope, so side effects are not visible to the caller. In order to propagate changes to the parent which call the function, you must use set var to value parent scope, which works the same as set but for variables belonging to the caller's context. While not necessary for this exercise, it bears mentioning that macro and function both support variadic arguments via the argv variable. A list containing all arguments passed to the command, and the arcn variable containing all arguments passed the... Okay, this is not important. We're not going to build any targets in this exercise, so instead we'll construct our own version of list append, which adds a value to a list. Okay, what's the goal? Implement a macro and a function which append a value to a list without using list append command. The desired usage of these commands is as follows. Set letters, macro append, message. Okay. Okay, let's edit exercise 1. Exercise 1. Implement macro append. Easy. Am I right? Okay, it's totally not easy. So, a list is just a string. What can we use? Macro and function. Macro is to create a macro. Function is to create a function. Set is to change the value of a variable. And if is like conditional. Okay. Now, this is the name of our macro. List var and value. Okay, this is the value which we will append to our list variable, which is just a string. This is to do one. Final expected value is... Okay, like, can we just do set and then the list var to be... how was set used? Like this. And how was that thing used? Like this. So we are setting this to be the same, but we'll get the value like it will be in a string where we get the value. How did we get the value? Okay, the curly braces. Oh, come on, man. And we do the semicolon and the like value, like easy. And it should be the same for the function. And we do CMake p exercise 1 unimplemented or did nothing. Did I do something wrong? Man, CMake experts that randomly are... Oh, yeah. The function can do it, but I don't think the macro can do it because, like, right? We had to use that special set. Set parent scope, this thing. Parent scope. Yeah. Because the function, when I set list var, it's in the scope of the function, right? Let's see if just CMake -p is enough. It contains tests to verify you're not expect to handle the case of an empty or undefined list to append to. However, as a bonus, we want to try out understanding CMake conditionals. Build and run. Yeah, this is what I did. Okay, so let's see what the goal is. Okay, we have letters. We have the like function or macro. We set the var and the value. And then there's a message. Like this should be changed. Like this that they set outside of it should be changed. And what I'm getting is unimplemented or did nothing. So the variable that has been given wasn't changed. That's the issue. Yeah, here is the test. Here is the original and the expected. Macro append. Oh, I'm not reading these. Implement macro append. And then I have to use the macro as well. Implement macro append. Yeah, I did it. Call macro append. Then return the value from... So I have to use macro append. Macro append. And then list var value. And then that return thing. Return list var, I assume. Okay, what happened? The return, okay, the return command was the issue. Okay, I can do it in another way. That setting, like set to be the same, but parent, like what parent scope. Yeah, but they do nothing. We'll get to the bottom of this. I'm missing something small because we didn't go that far. We can create a variable which is to say a name for a string using the set command. A variable's value can be accessed using brace expansion. Yeah, we accessed the value here. We access the value of the list, which is just a string. We added a semicolon and the value of this variable, which is also a string. Because CMake one has only strings. Okay, not this. As mentioned, lists are string containing semicolons. Yeah, list containing semicolons. We know that is useful for manipulating these. Yeah, but they told us not to use the list append. Allows us to craft our own functions and macros. We do so like this. It creates... should I be using like message. What if here I do message and it's like that? Okay. Definitely not that. We'll get to the bottom of this. One way or another. Okay, the macro, then the function, and then the function. Like with many languages, the difference between functions and macros is one of scope. Both function and macro can see all the variables created in all the frames above them. Okay, so since the macro is below, it can see to the top and the functions as well. However, a macro acts semantically like a text replacement. Macro creates are visible in the calling context. If we create or change a variable in a macro, if we change a variable, like this is important, in a macro, the caller will see the change. Function creates its own variable scope, so side effects are not visible to the caller. In order to propagate changes to the parent, which call the function, we must use yes, this thing. The var, the variable parent scope, which works the same as set, but for variables belonging to the caller's context. Okay, so doing set and the variable, this will change the actual variable. This will change the variable. Doing it without parent scope in a function will not change the variable for whoever called it. Also, we don't need to do this. But since the macro isn't doing anything, this will not as well. Oh no, the macro will change the functions list var. We still need to propagate it, yeah, like this. But they say that no changes have been made. How do they know? If is equal to the original. Unimplemented or did nothing. Not did nothing. Okay, let's do something. Let's do something with it. We'll set it to something else. Let's break it. Hi. Let's see if everything is working correctly. Unimplemented or did nothing. This is important. It did nothing. Unimplemented or did nothing. How do they check? The begin list is given and the begin list is compared to the original, and if it equals to the original, unimplemented or did nothing. If end list is equal to the expected, else is correct. Okay, we have, let's see here, we have beta and gamma elements. The expected is to have alpha, beta, gamma, delta. The begin list is original. The end list is alpha. Macro append. So we use the macro append. Yo. Yeah, we use the same macro append to the begin list to beta, gamma, delta, to add delta to it. And then for each value in begin list, we add it to the end list, which we add to the list with one element alpha, we add beta, gamma, and delta to the end list. And the original is just beta and gamma. If begin list equals to the original. Okay, if since all of these commands, the begin list is still as the original, so as we have set it from the start, we will get this like unimplemented or did nothing. So they're calling here macro append begin list with delta. And this is doing absolutely nothing. Okay, let's try to do something. Test. And this is weird because we are setting list var to like something completely different. And here we are doing like calling the macro on this variable. It should be different than the original. It should be different. This, we shouldn't be landing here. We should be here, like getting a warning that the end result is like what's expected. Final value. Then bonus tests. Let's see how to implement a macro. CMake. Not Siri. Yeah, macro, name, and arguments. And then commands and macro. The text argument. And macro commands. That. Yeah, I'm looking for examples for macros to compare with my own. CMake list set a variable. No, yeah. Set variable and value, and maybe parent scope. Set a normal environment variable to a given value. Signatures of this command specify a value. And if at least one value is given, set the variable to that value. If no value is given, unset the variable. It will be set in the scope above the current scope. Each new directory or function command creates a new scope. A scope can be also be created with block. Set parent scope will set the value of a variable into a parent directory. This should be working. For here we can, of course, try like set parent scope as well. But I always exercise one, right? This problem relies on understanding of the mechanism of CMake variables. Are names for strings or put another way, CMake variable is itself a string which can brace bound to a different string. It leads to a common pattern in CMake code where functions and macros aren't passed values, but rather they're passed the names of variable which contain all values. Thus list var does not contain the value of the list we need to append to, contains the name of the list which contains the value we need to append to. What? When expanding the variable, we'll get the name of the list. We will get the values the list contains. We need only combine this understanding of this var with our knowledge of the set command. This was a mindfuck. So list var is the name of the list. It's not the value of the list. Set list var. Okay, if I do it like that. Macro pen final value test. Yes. That was it. Like that was very important. Why didn't they say it sooner? Oh my. We set the value of the list to like this and this. Like No, yeah, that's the name, and the value is list var, and then value. Oh my god. And macro append is correct, and this unimplemented or did nothing. Macro append. We're giving macro append the name of the list. Then return the value from func append. We can do, no, it's a list. We're passing a list, but it's the list of the scope of the function. So we need to set it once more. We need to set it once more. List var to itself. To its value of the list, but with the parent scope. Final value. The final value is value. Oh, here, value. No, list var. Okay, what's the problem? We are setting the list var to value, but since we're in a function, like the macro is just like as if we had this. We are setting the list var. This is the name of the list. We are setting it to its value, which is a string, concatenated with the semicolon, and what we're appending. But this list var is in the scope of our function. And so I am setting it once more, but to this. Okay, we can, let's say that it should be like that. We regressed. Like this. Function invoked with incorrect arguments. For function name, function append. Incorrect arguments. Let's see here. Macro append, yeah, it's the name. And this, okay. Yeah, that's what we did with the macro. When expanding the variable, we will get the name of the list. Okay. It's still confusing. I want to see what does list list to a common point CMake code where functions and macro aren't passed values. This problem relies on understanding of the mechanism of CMake variables. CMake variables are names for strings. A CMake variable is itself a string, which can brace, expand into a different string. So a variable is a string that is a name for a string, like a reference. But before we didn't use them like that. Like here we set the variable as this. Right? If that what they said was correct, letters should be uh, and here I thought this will be easy. Okay, we don't need to worry about scope here because a macro operates in the same scope as its parent. It's almost identical. In fact, it could be implemented in the same one-liner, but with one with another. Let me just try one more time. Like this. Okay, let's see the result. Yeah, that's what I did. Oh, oh my. What we're missing is passing to the function the names. Oh, I get it. Inside of here, when this variable is literally like the string, like it's not any fancy like names of the variable, like those complicated things. It's just within functions and macros when passing along arguments. The mechanism of CMake variables. CMake variables are names for strings, or put another way, CMake is a string which can brace expand to the. This is to a common pattern CMake code where functions and macros aren't passed values, but rather, so it's not. It was just that functions and macros are not passed by value, but passed by reference in some weird way, which contain those values. Thus, list var does not contain the value. Okay, so when we're like when we get here from the function list var, the list var is not the list, it's a variable that points to the list. And here we dereference it, said in another way. And the value as well is the same thing. Have to dereference it. And then here once more when setting and doing this. Yeah. And the reference again, but inside the parent scope. Okay. Okay. I don't know where I'm going to use this knowledge, but now I know it. Yeah, here we have to the reference. Here as well. And here. As well. And the empty list case, well done. Oh, thank you. Well done. But here, when learning from tutorials, the important thing is not to solve it on your own, but to, at the end of the day, understand, to learn something. It doesn't matter if you had to see the solution. What matters is if you actually tried your best and understood in the end. Or just copy them. Macro append transforms list var for us, but it won't propagate the result to the parent scope because this is a function we need to do it to ourselves with set parent scope. Conditionals and loops. Man, we're 50 minutes in. We are not going through the half of the whole tutorial. Two most common flow control elements in any structured programming language are conditionals and their close simply. There were some other things, some other to-dos. Bonus. There was a bonus. Okay. Well, we don't have time for that. The most common CMake clank is no different. As previously mentioned, the truthness of a given CMake string is a convention established by the if command. When given a string, if will first check if it is one of the known constants values previously discussed. The string is one of those values. The command assumes it's a variable and checks the brace expanded context that variable to determine the result of the conditional. So checks if it's one of the known const values, else it's a variable and has to see its value. If conditional value, undefined variable, else undefined variable false. Set conditional value to true. Define variable true. Okay, if it's not defined variable, it will default to false. If it's a defined variable, then it looks at the value. Here it's true, it goes to here. And here is just a constant. This good time as any to discuss quoting in CMake. All objects CMake are strings. Thus the double quote is often unnecessary. CMake knows the object is a string. Everything is a string. In CMake, everything being a string is like in Linux, everything being a file. However, it is needed in some context. Strings containing white space require double quotes, else they're treated like lists. Concatenate the elements together with semicolons. Verse is also true. So some inside quotes if you want to preserve the semicolon. We'll expand the list items into space separate strings of commands such as if recognize the difference between quoted and unquoted string. We only check that given string represents a variable. Finally, if provides several useful comparison modes such as string equal for string matching, define if existence of a variable matches for level expression check. All supports typical logic operators. Turn to conditionals, CMake provides two loop structures while follows the same and the more useful for each. For this exercise, we are going to use loops and conditionals to solve some simple problems. We'll be using the aforementioned from function as the list to operate on. Loop over a list and return all the strings containing the string foo. Those who read the command documentation will be aware that this is list filter. There is the temptation to use it. I have zero temptation to use. Okay, exercise 2. Exercise 2. This is the function filter. This is the name. This is the variable. Here we set it. Yeah, this is just to set it as for the parent scope. Here is what matters, what we do. Search all the variables in the argument list, pass to filter. Argument list. Okay, out var is a list. And place those containing foo into the list named by out var. Wait. Search all the variables in the argument list. Pass to filter foo, which is out var. and place those containing foo in the list named by outvar. Oh my. Contains tests to verify the append behavior described. Okay, it's append behavior. Should use the list append command this time to collect your final result into a list. The input can be consumed variable of the provided function. Oh, the function gets additional variables. The script, okay, how is it used? Check how is filter foo used? Out list and then this thing. And this is the out list. So the out list is empty. We are defining it inside the function. That's it. But afterwards, we are getting all these elements. And we have to check if in the out list that we've defined has all of the individual elements. I see. And how do we access them? CMake arcan holds the list of all arguments given to the macro. Arcan holds the list. Okay, it's a list of arguments past the last expected argument. Okay, yeah, so argn is what we need, as they said. So it's like this. Arcn. Yeah, this is the list of all the arguments like afterwards, after outvar. Outvar is like empty. So we have to do a for each, right? We make for each. Let's look at for each and end for each. Loop var will be this. This will be the loop var. And no, this is the items. This is the item element. Can I do it like that? Element. For each element in this list. And I suppose we first have to define our outvar. Like we dereference it. And let's like put it as being empty string, just so it's defined. I don't know. We'll do some tests to be sure. And here an if and probably an end if, right? CMake if. Yeah, and if. And then the condition. We have to check if it contains foo. Containing. How, like they said about like string equals if it equals, but not contain. Provides several useful comparison modes such as string equal for string matching, defined for checking if the existence of variable, and matches for regular expression checks. So we have to do a regular expression check. If element matches, CMake matches regex, the regex specification. Online regex. So if we have like full test, full hello, full world, if we just use full, okay, matches full. If element matches full. No, it should be all of it, like matches the beginning of it, matches end of it, matches any single character. Okay, let's do dot. Like there can be any characters before full and any characters after full, and it can be like here can be nothing and here can be nothing. Like I'm eyeballing this, we'll see. And they said we can use the append. We can use the append. List append, they said. List append. List append the list and element. List append the out var element. Exercise 2. Warning. Out list does not contain foo bar. Does not contain. Element. Oh my god. The value of element. Jeez. Success. Yo. I'm curious if we remove the set in the beginning, if it's a problem. No, it's not a problem. And I'm curious, so probably list like defines the variable. And here if we remove this, what? It's still a success. So it was not needed. The match was a success. So this is enough to be like, does it contain this thing? And if so, append it. Okay, what if we don't check for anything? We append all of them. Contains extra items. Okay. It works then. Yeah. Let's move on. Let's move on. Build and run solution. We need to do 3 things. Loop over arcane list. Check if a given item in that list matches full, and if so, append it to the outvar list. Oh, there are couple of ways we could invoke for each. One is to allow the command to do the verbal expansion for us via in lists to access the argin list items. Dev comparison we need is matches using to check if foo exists in the item. All that remains is to append the item to alvar list. And the trickiest part is remembering that alvar names a list. It is not the list itself, so we need to yeah, this is we learned that the hard way. Now they do for each item in lists arc n. Okay, the difference is from us, like I'm using like for each element inside this list, but here like instead of this thing, this the reference, they are using this. If the result is the same, they say it's better, okay, fine. If item matches foo, also they don't even like do these things because it's just assumed. Since it's not a variable, it assumes it's like string. If item matches foo list append, we append yeah with the reference it and the reference item like we did, yeah, exercise 3. I wanted to move faster than this, but it is what it is. It is what it is. Hopefully we can at least go through the current step, the current step we're at. We have already discussed how to incorporate subdirectories containing their own CMake lists with add subdirectory. In later steps, we will explore the various ways CMake code can be packaged and shared across projects. However, for small CMake functions and utilities, it's often beneficial for them to live in their own CMake files outside the project, separate from the rest of the build system. This allows for separation of concerns, removing the project-specific elements from the utilities we're using to describe them. Incorporate these separate CMake files into our project, we use the include command. This command immediately begins interpreting the contents of the included file in the scope of the parent CMake. It is as if the entire file were being called as a macro. Okay, so include is like in the headers where it's just like a literal copy and paste. And here they say that instead of that, we can package it and share it across project more complex than just the include. It is as if traditionally these kinds of CMake files live enough. So it's like organization. So you don't have one big CMake file. You have these separate files that you just include. Inside the project root for this exercise, we'll use the step 2 folder instead. Go use the functions from exercise 1 and 2 to build and filter our own list of items. Include files to edit. The source code is provided in step 2. It contains tests to verify. Actually, uses tests from access to make usable code is good for everyone. Okay, to do 4 through 7. To do 4 through 7. 4, 5, 6, 6, 7. You guys are not the target audience for that. Neither am I. Set the skip tests variable to a true value so that the tests from exercise 1 and 2 are skipped. Skip tests true include. Is that it? In list is foobar and qbar. Append foobus and qbus to in list with func append. We append to in list foobus and qbus. And here we are not like dereferencing, like doing this, because we're not inside some kind of a function call. To do 7, filter in list will filter foo in list, use out list as the output variable. Out list filter in list. Yeah, but filter by what? Foobar. Okay, in list we have foobar and qbar. We add foobus and qbus. So the bus and the bars. And the filter oh, the filter was automatic. The filter was automatic. Like if they contained foo. That was it. Filter foo. Out var. Oh, it's the other way around. Yeah, we are using the elements of the list, and this is like empty, like it will be defined afterwards. Yeah, let's test it. Let's test it. What happened? Out list does not contain foobar. At exercise 2. Keep tests. Keep test. Yeah, this should keep all the tests. I've set it to true. I've included the exercises. What's the issue? The issue is just warnings. But exercise 2, line 20, that foobar. Oh, it's just the yeah. It's the they're reusing the tests from exercise 2 and the yeah. So it's just that the foobar and the filter is not working. The filter is not working. Like these checks. These checks are defined from exercise 2. These functions. Check contains. Here, this message from line 20. That's why I'm getting like line 20 from exercise 2. The tests are actually skipped. It's these tests. Okay, the filter is not working. Filter foo. It takes the out var and then the list. How do they use it here? The in list. Look at how here they set it and then they use it as that. I suppose I have to do the same, but I would like to know why. Okay, success. Why though? Um, we set it the same way as this thing. Oh, I see. The way we've set it. If we do it like this and do it like this, will it work? No, it's the same. Yeah, it's the same. But this is like inside the functions, we pass, because in the functions we pass like the arguments are the name of the variables as if as some sort of reference, and we dereference it to get the actual value, which is the actual list. Yeah, it's still complicated. Someday I'll understand it when I get smarter. Build and run. The include command will interpret the included file completely, including the... We don't want to run the tests again. Those files check a variable called skip tests. Yeah, set skip test. We've done that. We included them. We used the function. And here we use the filter with this thing. With time and exercise, like this will become like more easier to understand. Okay, this was step 2. That was step 2. And so we've done the first task to open step 2 page. We've done this to read through the step 2 page. And I had these ones as a goal. Maybe we can do step 3 as well if we're like in 10 minutes. uh, Let's just have a quick peek to see what we'll be getting. Configuration and cache variables. Oh, it's the option thing. Like, I want to learn this because it's used here in glfw. Like those options. Here. Option. I want to know what they are. But maybe for the next stream. Okay, if use zlib, I will use zlib. If I will use zstd. On, off. On, on. So option is the same as like doing it inside of here. CMake build and like these flags that will be used in some if somewhere. Okay, so in glfw, this option here will be used somewhere inside of an if. Or maybe in some other ways, like here they've set a variable to that value. And this is maybe used in an if. Build shared library. Okay, options. Set can be also used. Then exercise. Exercise 2. Make presets. Yeah, we'll end it here. Yeah, thank you guys for watching. We managed to just go through step 2. And yeah, it was fun. Thanks for watching. See you next time.